Hey guys, it's Mitosis Perfectionalis, where medicine makes perfect sense. We resume our physiology playlist. This is the 23rd video in this glorious series. Today we'll talk about the Ficks Principle. So in this video, we'll talk about Fick. In the next video, we'll talk about Re. What am I doing with my life? Let's get started. Imagine that you have a beautiful test tube containing 3 liters of water, and inside the water there's sodium. If I've told you that the concentration of sodium in the water is 2 grams per liter, and this test tube contains 3 liters of water, please calculate the amount of sodium in the test tube.
Oh, that's easy, Mitosis. It's gonna be 6 grams.
Wow, genius. How did you do it?
Oh, since it's 2 grams per liter and I have 3 liters, 2 times 3 equals 6.
And this is the Ficks Principle. Amount equals volume times concentration.
So that's it?
Oh yeah, that's it. You can go eat cookies now.
So you're trying to tell me that dude named Fick got his name into the textbook just based on this formula that amount equals volume times concentration?
Oh yeah, that's it. Now you can go fick your... I'm sorry, this is too far. So amount equals volume times concentration, and therefore concentration equals amount over volume. No kidding.
Okay, Mitosis, now why should I care about Fick?
Let me tell you the story of water and body compartments. This was discussed in detail in my playlist called Fluids, Electrolytes, and Acid-Base Disturbance. So we will go over this very quickly. First, why water? Why is 60% of your body water? Why not oil or liquid mercury or whatever? Now imagine that your body was made of oil and you live in Arizona. You will literally sizzle and melt. Literally, not figuratively. And if your body were made of something else, you would freeze in Alberta. Water is lovely because it's the liquid with the highest specific heat.
What the flip does that mean?
It means water is very difficult to boil or to freeze. It takes a lot of energy. So that's why you're not gonna melt in Arizona or freeze in Alberta. Next, water has capillary action. Look at this. It's easier for water to go in a smaller test tube, and this is gonna be your blood vessel. Whew, saving time, saving money, saving effort, or as economists might say, we are economizing on scarce resources which have alternative uses. Next, water is an excellent solvent for all of the sodium, potassium, chloride, and other electrolytes all over your body. Also, water is important for the redox reaction, reduction, oxidation reactions. To kill bugs, we call this reactive oxygen species. And as Dr. Thomas Sowell said, there are no solutions in life, there are trade-offs. These reactive oxygen species can kill bacteria, they can also kill your own cells. When they first did these experiments, they did it on men in the military. So, adult male, total body weight 60%. Okay, adult female, only 50% of their bodies are made of water.
Why 50%?
Because females have more fat, therefore less water, because fat and water hate themselves. Or as a famous former Egyptian president once said, they don't mix.
Why do females have more fat?
You can talk to estrogen. Infants have a higher total body water percentage, 75% of their body. Oh, and that's why dehydration is a worse problem for kids than adults. To illustrate this, imagine 2 houses. This is made of 60% wood, this is 75% wood. Which one is more likely to catch fire, or which one will be affected more in case of fire? Of course, the 75%. Same thing here, 75% of the body of babies is made of water, that's why dehydration will destroy them. And you need to be very careful because dehydration is not the same as extracellular fluid volume depletion. Dehydration just means loss of pure water, but volume depletion is loss of water and salt. Therefore, if you have a baby who is dehydrated, what should you do? Just give water. But most of the time, it's volume depletion from diarrhea, vomiting, etc. If it's volume depletion, it means the baby has lost water and salt. You replace the water and you replace the salt, doofus.
But mommy has told me that the baby was dehydrated, not volume depleted.
Mommy is not a doctor. You are the freaking doctor. Use your brain.
Okay, 60% of my body weight is made of water. Okay, so let's say I'm 100 kilograms, therefore 60 kilograms are water. 2/3 of them are in the intracellular space, which means inside the freaking cell. And 1/3 is in the extracellular space, which means outside the dadgum cell. And then a smart student raised her hands and asked, Professor, why do we have more fluid in the ICF
than in the ECF. Because you're not a sponge. Like when I shake your hands, water's not just gonna fall out of your hands and all over the place. No, you're not a sponge. SpongeBob SquarePants will have more fluid in the ECF than the ICF, but not you. Most of your fluid in the ICF. Let's talk about the ECF outside the cell. We have some of them in the plasma. Some of that fluid is in the interstitial space. 1/4 is in the plasma. 3/4 is in the interstitial space, to be specific. And there is some fluid in what we call transcellular, and these are the 3 P's: pleura, pericardium, peritoneum, 2 lymphs, perilymph, endolymph, and 1 synovial fluid. So 60% of my body weight is water, 2/3 intracellular, 1/3 extracellular. Of that 1/3, you have 1/4 in the plasma and 3/4 in the interstitial space. So from the original, if I am 70 kilograms, 60% is how much? About 42 liters. Because a liter of water weighs 1 kilogram, because the density of water is freaking 1. 40% of the total body weight is in the intracellular, which is about 28 liters, and then the rest, which is 14 liters, is in the extracellular space. Of that 14 liters, you have 1/4 in the plasma, so 1/4 of 14 is about 3.5. There's another way of doing this. This is 5% to 15%. So 5% of what? Of the total body weight. 5% times 70 equals 3.5. Same thing. Let's just say 3 liters of plasma, and then you have 2 liters of red blood cells. And that's why when we do the hematocrit value, which is RBCs over the total blood volume, it's gonna be around 40%. So we have more fluid in the intracellular than the extracellular. And in the extracellular, we have more fluid in the interstitial space than the plasma. A smart student raised his hand and said, "Oh, Professor, why do we have more fluid in the interstitial space than that of the plasma?" He said it with such unction in his voice. Okay, big boy, listen. Imagine that you joined the military and you received a bullet and started bleeding. Would you prefer to have the majority of your fluid in the plasma and therefore lose it all and die? Or would you like to have a reservoir of fluid in the interstitial space, 3/4, so that you can replace the lost fluid until the ambulance comes? Medicine makes so much sense once you understand what the flip you're talking about. Quick question. We know that the fluid inside these cells is intracellular fluid, and we know that anything outside is extracellular fluid, and they include the plasma and the interstitial space. Now here is a question for you. The fluid inside the red blood cell, do you consider this intracellular or extracellular? Since we call these red blood cells, anything inside of them is intracellular fluid, doofus. In my playlist about fluids, electrolytes, and acid-base disturbance, I freaking told you that not all waters are created equal. We have obligated water that follows the sodium obligatory, and we have the free water, facultative water. She's free. She does not follow electrolytes. The obligated water is absorbed by aldosterone. The free water is absorbed by ADH. For the obligated water, the channels are called aquaporin 1, but for the free water, the channels are aquaporin 2. And the mnemonic is, the water is free to live, free to choose, which is a book by Milton Friedman. In a nutshell, water is special in physics. That's why most of your body is made of water. You're not a sponge, therefore, most of the total body water is in the ICF. We need a reservoir in case of bleeding, therefore, most of the ECF is in the interstitial fluid. And this is the idea of the hematocrit value, and we have talked about this a zillion times before. Here's a question for you. How many types of ATPase pumps are in your body? Let me know the answer in the comment section. Question number 6. Please match from this column to this column. Okay, here is 1. Oh, and here is 2. Cool. Here is 3, and here is 4. Which one is simple diffusion? Which one is facilitated diffusion? Which one is osmosis, primary active or secondary active? Go! Here is the third question for you. By the way, I called it 7 because the previous questions are in previous videos. How many liters of normal saline do you have to infuse into the patient in order to deliver just 1 liter to his or her plasma compartment, assuming that this is a patient and he's an average male of a body weight of 60 kilograms? Let me know the answer in the comments. You'll find the correct answer in the next video. Now you understand water and body compartments, let me tell you the application of Mr. Fick. I need to open a restaurant called Ficks Falafel. Oh man. It's like Papa Murphy. Bake your own pizza. Yeah, fry your own falafel. God help us. How can I verify what you said, Mitosis? Because I do not leave those professors and those textbooks. Maybe this is just a social construct in your heads. A social construct? It's as if reality is optional. Hey, big boy, come with me to the lab. I'll show you some magic. I'll bring an indicator that's going to be used to measure these compartments. This indicator that's going to be infused into your body has to be inert, not toxic, and not used by your tissue, because if it's toxic, it's going to kill you. If it's used by your tissue, you will not find it because it will be consumed. We need it to stay as is so that we can measure it.
Oh, fine. How would you measure my total body water, which is 60% of my total body weight?
By using heavy water. D for deuterium, if you remember those good old days of chemistry.
How would you measure the ECF?
By using inulin. Have you ever heard of inulin biochemistry?
No, never.
That's the point. We need to give you something that's foreign to your tissue so that your tissue will not be able to deal with it and it's going to stay. If it's going to stay, it's going to be easy for us to measure it. Or you can use sodium thiocyanate. Have you ever heard of sodium thiocyanate? Oh, you need to watch my video on cyanide poisoning.
How are we going to measure
Plasma. Give something that's gonna stay in the plasma and not going anywhere else. It's not going to the interstitial space, and God forbid, it's also not going to the intercellular space. Oh, what's this? You can use Evans blue dye, not to be confused with Ivan the Terrible. Plasma proteins labeled by radioactive iodine. Oh, of course, if you have plasma proteins, they are gonna stay, guess what, in the plasma. If they stay in the plasma, you can measure them in the plasma. Same thing with inulin. Inulin will only stay in the ECF because your cells cannot deal with it. It's gonna stay outside.
Okay, Mitosis, this is beautiful. Now I know that my total body water is 60%, and now I know that the ECF is about how much?
1/3 of my total body water.
Now I understand that my plasma is 1/4 of my ECF. But how about the ICF and the ISF? You just use your brain, calculate them. Oh, ICF is the total body water minus the ECF. How about the ISF, interstitial fluid? Easy, it's the ECF minus the plasma. So what the flip does that have to do with Fick?
Remember, Fick is volume equals amount over concentration. A known amount of an indicator is being injected into the patient intravenously. Time is allowed for the indicator to diffuse in water of your whole body, and then a sample of blood is taken to detect what? The concentration. You can measure this in the lab. If you know the amount, if you know the concentration, you can calculate the volume. All of these are volumes. And this is how Fick is freaking fabulous. What's even more fabulous is my cardiac pharmacology course. Go to medicosisperfectionalis.com. I have 50 videos on cardiac pharmacology plus 25 cases with answers plus my notes. You can download all of these right now. I love you guys. Please subscribe, hit the bell, and click on the join button. You can support me here or here. Go to my website to get my antibiotics course and my cardiac pharmacology course. Thank you for watching. As always, be safe, stay happy, and study hard. This is Mitosis Perfectionalis, where medicine makes perfect sense.